All right. Another part of expected value is how it's used for like insurance policies. So let's say you work at an insurance company and this data here is provided by Social Security and it is the probability that you're going to die given your age. So if you're 43 years old and male, this would be your probability. Now insurance companies, their tables are much more extensive. They deal with if you're smoking, if you drink, if you're obese, a lot of different things in their tables to come up with the probability of an individual dying. But Social Security is just generally worried about if you're going to die or if you're going to live. So they base it on these statistics. All right, so let's say we're looking at a policy for a 45-year-old man. So his probability of dying within the next year is 0.003297. So his probability of living is the opposite of that, the 1 minus thing, the complement. All right, so let's say this guy wants to get a policy for the next year and he wants $50,000. So he wants a $50,000 life policy and it's going to cost him, let's say $265.73. Yes, they want all their money. All right, so if he wants this policy for this much money, the insurance company knows exactly how much profit they're going to make on this type of policy with this cost. So what you do is you separate your table into, let's go with the darker blue, two events that possibly could happen. The person could die, or the person could live within the next year. All right, so that would be the description of what would be happening. If the person dies, they're paid out $50,000. So the insurance company is literally going to lose $50,000. But they charge the person $265, so they'll at least have that as a positive and 73 cents. So total-wise, let's see, that's 50,000 minus 265.73. So they'll be losing, let's see, $49,000, 49,734.27. The insurance company will be out that much money. Now, if the person lives, then you get to keep the $265 and not pay out anything as an insurance company. Now, if this was backwards, like if you were worried about your insurance costs, then this number would be negative and this number would be positive. In other words, if you died, then this would be paid out to your family less the $265.73. All right, so the next column, we'll leave this alone, $265.73. There's no calculation on that one. The next one would be the probability of this person dying. Well, the probability of them dying is that number over there. So this would be 0.003297. And the probability of them living is 1 minus this number, the complement. So 1 minus 0.003297. So their probability of living over the next year is 0.996703. Sounds pretty good, actually. All right, so when we do expected value, once you get the probability and what could happen together, these two numbers are going to get multiplied together, and these two numbers are going to get multiplied together. Don't forget that point. And their answers are literally going to be added, well, in this case, subtracted because it'll be negative. So when we do that, it'll be negative 49,734 and 24 cents times the probability of dying, 0.003297, and then add on to that 265.73 times 0.997, nope, 996,703 for a grand total of $100.88. All right, so what happened? Well, when this insurance company sells their policy for $265, they are pretty much guaranteeing themselves if the probability of dying is correct, $100 profit every policy. So basically, this company is ripping off its customers. Oh well, that's how insurance companies work.